Hello everybody, and thanks for having me at this conference. My name is Bernhard Fritsch and I'm currently working for the German Archaeological Institute in Berlin. A few words to my background. As I said, I'm an archaeologist and not an IT expert, but I started working with 3D data back in 2008, and since 2014 I also worked in the field of research data management and with online platforms or repositories in order to publish research data and especially 3D data. And now I would like to talk a little bit about what problems can occur when trying to publish 3D data of an archaeological content. First, I would like to recall what kind of 3D data we talk about, so what techniques are commonly used in archaeology. We do have laser scanning, which is used to scan, for example, large buildings or architecture, as well as bigger areas or landscapes. As all of you know, the results of laser scans are very huge and dense point clouds. Then there's also structured light scanning, which is often used for smaller objects, not so often for architecture or excavation documentation. This method is very good for capturing objects in museums, for example. The basis of structured light scanned model is also dense point cloud, so both methods can be called point-based 3D scanning. And then we do have the method of structure from motion, which is a technique that became very popular in archaeology in the last years. It is almost a standard method nowadays, and the reasons are that the method is relatively cheap and first and foremost it is very flexible. So you can capture small potshots of a few centimeters as well as bigger architectural structures and also landscapes, as you can see in the lower right corner. Here you can see also a mix made out of a drone imagery and underwater photographs that were merged in one model. And especially for the documentation of an excavation, meaning archaeological trenches, structure from motion is almost a perfect tool. Also here, the basis of the 3D data is a dense point cloud, so SFM can be grouped with laser scanning and structured light scanning when we consider the topology of the 3D data. But then there's also a long history in archaeology in using 3D models that were generated in CAD software or programs like Blender or Geomagic. You can also face a combination of the different methods, as you can see in the lower images, where a SFM model was added with parts created in Blender. But the important point here is that these models are not point-based, but NURBS-based. The basis of these models is not a dense point cloud, and as I learned in the last years, this can be a problem for web viewers. Just to illustrate this issue, you can see here on the left side a small model of an ancient architectural fragment created with structure from motion, and you can see the mesh behind it, which is very dense, and you can also see the dense point cloud, which is again the basis for the mesh. On the right side, on the other hand, you can see a model that was created with SketchUp, and if you change the visualization mode here, you can clearly see that there's no dense point cloud behind it and the faces are quite large. If we now speak about web viewers, we can see that there do exist really wonderful solutions, like for example 3D Hop or Pottery. The problem is, as far as I have understood, that unfortunately no web viewer can handle all the different kinds of 3D data in terms of its geometry in the same quality. You can see on the left side that in 3D Hop there can occur a little bit of strange visualization if you load a NURBS-based model. The huge faces are not really like they should be. And on the right side you can see a Pottery example, which is great for huge point clouds, but on the other hand Pottery cannot handle bigger meshes, no matter if point-based or NURBS-based, as far as I'm aware of. So this is the main challenge for an archaeological publishing project, that you cannot cover all your data with one viewer. Besides, there are a few things more to consider. A very important feature in using 3D for the documentation of excavations is that you want to have georeferenced models. This is necessary to document the different layers of an archaeological trench, and by doing that, you also need a very high precision of a few centimeters. If the overlay of the layers is not correct, this can lead to a complete misinterpretation of the situation in terms of the stratigraphy. And since stratigraphy is the core element of archaeological research, it is very important to have a correct documentation here. Now when you use, for example, a total station at the excavation, it is no problem to georeference the 3D model with the coordinates measured. You can see on the left how such a PLY file looks like. The vertices are just the same as in that case UTM coordinates. But if you load this file into a web viewer, the representation of the model is completely wrong, as you can see on the right side. On top you can see a mesh, on the bottom you can see a point cloud. This happens due to the use of the floating values in WebGL or OpenGL that cannot work with such long numbers. So it cannot work with the real-world coordinates. You cannot load a georeferenced model easily into a web viewer. The second problem can occur when a lot of texture files are used. Texture files are great to visualize a 3D model, but in archaeology they are not always necessary, and they can also cause some problems when it comes to publishing a 3D model. This is simply due to the fact that the texture files nowadays can be really huge files, and they can be more than one. When moving the model from one file location to another location, one of these files can easily be lost or can get corrupt, or a changed name of the file then makes the model look like you can see in the example on the right. Plus, but I admit this is not necessarily a problem of a web viewer, texture files can cover wrong geometry, so again the interpretation of, for example, a layer of an archaeological trench can be misinterpreted. Now let's get back to the publishing process. Nevertheless, I think 3D models are an important part of the research and are definitely worth publishing. And by publishing, I mean that a 3D model in itself is worth to be considered an own resource to get published, not only as a supplement of a text. But then you need, of course, to fulfill a few requirements that are necessary to count as a publication in an academic sense. This includes enough metadata, meaning at least the bibliographical information such as the name of an author, a title, publisher and publication year, and a clear identifier. By identifier for publishing research data online, we speak of persistent identifiers such as, for example, a DOI. And of course, it should be possible to download the data so that other researchers can understand the data and the creation of the data. My current impression, if we talk about publishing of 3D models, is that unfortunately in the most cases there are still just screenshots of the models used. This downgrades the 3D model back to a 2D representation, and a lot of information is lost. There are some journals that already offer to publish the real 3D data with the help of a web viewer, such as the Studies in Digital Heritage. But for some reason that I don't know, you don't find a single example of an active 3D viewer in the already published volumes. So it seems that the archaeologists still prefer using screenshots, which is kind of sad in my mind. And this is sad because there are solutions for that problem if you put your data into a repository and if you use a web viewer. This is why web viewers are extremely important for the whole publishing process. For academic institutions, there are some requirements to consider by building repositories and publishing platforms. The use of open source tools is important to guarantee the exchange of knowledge between researchers. That's the basic principle, because everyone must have the chance to see and use the data without buying software that maybe some of the researchers simply cannot afford. But of course, I'm sure that there are sometimes also other financial reasons, for example due to the fact that it is, at least in archaeology, very hard to find IT experts because they get paid better jobs everywhere else. So often archaeologists with a bit of interest in IT, for example like myself, have to deal with the software, which means in consequence that use of these techniques may not be too complicated. But this also complements to the so-called FAIR principles, which came up a few years ago. The FAIR data principles were elaborated and published in 2016 by members of the Force 11 community, a coalition of different stakeholders to improve the use of IT technology. The aim of the FAIR data principles, an acronym for findable, accessible, interoperable and reusable, is to prepare research data for humans and machines following the aforementioned criteria within the scope of what is legally and technically possible. The FAIR data principles were mandatory included in the funding guidelines of the EU Horizon 2020 program, as well as in the German NFDE initiative to establish a better infrastructure for research data, and I think they are really very useful when working with research data in archaeology. I am quickly trying to translate these principles to understand what they mean in practice. Findable means that the data can be uniquely identified and can be found in search engines or catalogs due to the metadata information that is connected to the data. Accessible means, as is written here, that anyone with a computer and an internet connection can access at least the metadata. This is, for example, the case if a repository does not use a web viewer for 3D data, but the data is at least listed in the repository. Interoperable means that you can download the data and open it with other tools, so providing a 3D web viewer alone is not sufficient. And reusable means that everyone can work with the data, use it for further research, but also that everyone can retrace how this data was generated. There are already very nice examples in place that offer 3D data and also meet the requirements of FAIR data. I just would like to show you two online repositories. The first is Open Context, which in my mind offers FAIR data, but this is just my personal assessment, that is not an official seal or something similar. But on this website you find a set of 3D models with rich metadata, license information, persistent identifiers and also the possibility to download the data. But at the moment There is only one set of very similar models in terms of the geometry. They are all point-based, there is no NURB-based model. For that reason, the Webviewer used works perfectly. And that is exactly the same for the other experimental, the repository of the University of Heidelberg. There you can find a large number, I think over 1000 3D models of cuneiform tablets. Again, there's rich metadata, license information, persistent identifiers, and you can download the models. But again, this is one similar set of point-based 3D models. And there are of course commercial providers. You probably all know Sketchfab, which is widely used also for some museum collections. But the problem here is that you cannot really cite this data in an academic way, and you have limitations for the number and size of the models. So you cannot provide the highest resolution, and hence Sketchfab does, in my opinion, not meet the fair data principles, and so it cannot really be used for hosting research data. The same applies for Cesium, where you could in theory publish also Georeferenced 3D data. But of course you can use Sketchfab to quickly share your data just to show the data to someone else. But for this purpose there's also another very nice platform, the Visual Media Service. Here you have also limitations regarding the size of the models, but the intention of the service is only just to provide a possibility to share data, not to publish it in an academic way. Okay, getting back to open source Webviewers, which we want and need to use in archaeology. At least for point-based models, there do exist workarounds to handle large 3D models that have textures and are georeferenced. By converting these models into a compressed file, you have a decent visualization of the model in the viewer. This works fine with the Nexus compression of 3D-Hop, but the exact georeferencing information as well as the single textures are lost in this step. This means even if you can download the compressed format, you cannot use this file for further research. The model is not interoperable or reusable anymore, so we lost the fair data. A solution to that problem is that a repository should offer two versions of the 3D model. One is a visualization model, which is used only for the Webviewer, but the version that you get when you download the model should be the original model, so that you get the highest resolution of the model, all texture files, and also the geospatial information in the case the model is georeferenced. This way it is possible to have very nice visualizations of the models, as well as the possibility to actually work with the data. But in my mind, not a lot of archaeologists are aware of these issues. Please correct me if that is not the case in other institutions or countries. Maybe this is just my personal impression here. But what I'm actually also missing when I look at some repositories, there are no precise publication guidelines for 3D models available. There's always a list of accepted file formats, but I have not found much information about problems with georeferenced models or texture files. So I think such guidelines should be written in order to promote the publishing of 3D data. Finally, a quick outlook. As I already said, my personal impression is that archaeologists need to know more about how Webviewers work, what they can and what they cannot expect from them. And I also think that archaeologists also need more information about the fair data principles. So it should be clear that putting a 3D model into Sketchfab is nice to show the data to others, but that is not enough. If you cite such links in publications, no one probably knows how long these links will be valid, and no one wants to have dead links in books and articles. So I would like to finish with a question to the IT experts here. How are the chances to have an open source Webviewer that can show both point-based and NURBS-based models in the same quality? Because this seems to be the biggest issue right now when it comes to publish 3D data of archaeological content. Or is it an illusion to have such a viewer one day in the near future? Thank you very much for your attention.